Hello everyone and welcome to my channel Mathematics Made Easy. Today I'm going to be in this video showing you the most requested topic on my channel, and this is going to be a must watch video for all the grade 10 students who have given their math exam recently. So you can use this video to check your answer for module 9 trigonometric function, and don't forget to watch part 1 and part 2 of the revision series, and you can also check your answers for the exam that you have given using my videos. I'll put the link in the description box, so make sure you check all your answers for part 1 and 2 as well. So let's dive into this video, and this is going to be a complete revision guide, a complete answer key for trigonometric functions. So let's get started. Okay, so this is about the revision of trigonometric functions. There are different lessons in this module. I have taken the important ones for your end of term of 2, and also I have taken this from the list of important questions that have come. Some of them are long word problems, so we are going to break them and do them as a part of our trigonometry series, which is going to start very soon, wherein you will get one video for each important question from trigonometry. So it will be like one math problem per day from trigonometry for the next coming days. The revision with this sheet. This is the sheet of all the formulas that are there in this module 9 of trigonometry, and we are going to, you can use this sheet for reviewing, you can use this sheet for learning the important formulas that will help you for solving the question. So let's come to lesson 9.1 and 9.2 first. Here you had done about trigonometric functions and angles. We had talked about coterminal angles. We had talked about the conversion as well. So when you have an angle that is coterminal with another angle, then you can find it by adding or subtracting a multiple of 360. So this will be like a rule that you will use, and we'll see in the slides to come how you can use this rule for finding the coterminal angle. So rule is either you add 360 a multiple or you subtract 360. Now because it's a multiple, you can multiply it with n. It can be n equal to 1, 2, 3, so on. Next is the formula to convert degree to radians and radians to degree. So I will also show you in terms of questions how you can apply this formula. That's why I call this a formula sheet as well. Next is what is the formula for all the 6 trigonometric ratio. So 6 trigonometric ratio for a right triangle you can find using these formula for the ratios. Okay, and then finally for lesson 9.3, where we did about circular and periodic function, we had talked about the unit circle, we had talked about the formula for the terminal side. So if the terminal side of an angle theta in standard position is given to you and it is meeting at the point px comma y, this is for the unit circle, then the x coordinate will give you the cos value and y coordinate will represent the sine value. So that's the formula for finding the point and the values. Here you can use this formula to find your theta also, or in the question theta can be given to you and you have to find the coordinates of the point. Both kind of question can come. Next we'll talk about periodic functions, and sine and cos are here your periodic functions. So sine x plus 2 pi is sine x, cos x plus 2 pi is also cos x, which tells you that the period for sine and cos is 2 pi, or after every 2 pi intervals sine and cos is going to repeat itself. Coming to tan, these are also periodic function. However, for tan and cot, the period is different. It is pi, and you will also see how you can solve questions on various periodic functions in this lesson. So you will get some questions in coming slides on that as well. Next, you learned in lesson 9.4 and 9.6, even 9.5 about the graphs. So we talked about the graphs of trigonometric functions, sine, cos, tan, cot, all of them. You can also use the equations of reciprocal. So reciprocal of trigonometric functions you can use for this relationship. So 1 over sine, 1 over cos, 1 over tan. You can find the reciprocal using that. Next, we talk about some important features or key features of the trigonometric function. You will see questions on how you can find frequency, how you can do the graph, how you can find the period of all these trigonometric ratios. Last but not the least, important formula for phase shift and vertical shift. This is the one which is going to help you. We'll see in the slides to come how we can solve questions on phase shift and vertical shift using this for sine and cos. Next is inverse trigonometric function, the last lesson for this module, where you use this concept of inverse to find the angles. So the inverse of a trigonometric function transposes the x and y values. It exchanges or interchanges. So if y equal to sine x, then x equal to sine y. Remember, inverse trigonometric function is used to find angle for trigonometric function. So this is a quick review of module 9 and the formula sheet. Let's now use this for solving questions. Okay, so let's do the first few questions. These are simple questions which are given on page 421 of your math book, question 16 to 42, and they work on the concept of converting the angle from the unit of degree to radians and vice versa. So let's select a few of them. These are too many, and all of them are going to be solved using the same formula or the same method. So let's see which ones we are going to be doing in the session. So we'll work on 16. Then we'll work on 17. Next we'll work on 29, and then we work on 30th. Now I've selected these four is because the first two are the angles which are given, one with positive, one with negative sign, and these are in degrees, so you need to convert them into radians, correct? And the next one, 29 and 30, are given in radians. One is positive, one is negative. So here in these 16 to 33 question, you have to find the angle with a positive measure and an angle with a negative measure that are co-terminal with each angle. And then finally in 34 to 42, you have to rewrite the given measure. If they are given to you in degrees, you have to convert them into radians. So let's see the key concept as I had provided in the last slide for you. So the key concept that we are going to be using here for question 16 to 33 is that in a case you need to find positive measure angle which is coterminal, and similarly for a negative measure angle which is coterminal, the concept is you add or you subtract a multiple of 360. So 360n, because it's a multiple, and this n can be any integer. Now since we need to just find only one positive and one negative for each part, so what we'll be doing, let's do one part out of it. So 65 degrees is the given angle. Now I need to find one with a positive measure, so I can add 360. Why I'm adding here? Because addition will give you the same sign of positive. And to find a negative one, you can subtract. So you subtract 360. Now remember, in this case, I'm taking n to be 1 because we just need to find only two angles, one positive, one negative. So this is not going to be very difficult, and n equal to 1 will going to be helping us. So let's add them. This comes out to be 425 degrees, and when you subtract, it comes out to be 295. So these are two coterminal angles, one with a positive, one with a negative measure, that are coterminal with 65, the given one. In a very similar way, your answer for 17 would be same way, negative 75. Now a negative angle is given, so you add 360, you get one angle which is positive, you subtract 360 and you get an angle which is negative. So you can do this calculation, and that's how question 16 and 17 will be done. Talking about question number 29 and 30, there will be no difference in the formula except the fact that because you know 360 degrees is equal to, so I'm just going to write here, add to the key concept. Let me change color, it will become more easy. So I will add 2 pi radians, right? Because you know 360 degrees is equal to 2 pi radians. That's the conversion. And similarly, subtract 2 pi radians. So that's the only change in the key concept while we are solving 29 and 30. So when I talk about positive angle, I'm going to definitely add 2 pi. And when I'm talking about negative, from this angle which is given, you are going to subtract 2 pi, right? So that's what you are going to be doing for finding coterminal. Now, how further you do? I hope all my students know the concept of LCM. So here you need to make the denominators equal in order to add or subtract. So let me do that simplification over here. So 5 pi by 6, first I'm finding the positive. Now I need to make the same denominator, means the denominator has to be 6. That means for this 2 pi which is given to you, I multiply numerator also by 6 and denominator also by 6. It will not change the fraction, but it will make the denominator same. So what is the common denominator now? 6. And on the top you have 5 pi plus 12 pi. So 5 pi plus 12 pi would give you 17 pi. So that will be your answer. Correct? And similarly for the negative one, once you make denominators equal, this will come out to be 5 pi by 6 minus 12 pi by 6. So you subtract the numerators and you get the coterminal angle to the given angle 5 pi by 6 with as negative measure, right? So I'm sure similarly you'll be able to do question 30, and now we'll proceed to the next slide. This one is full here, and we'll do question number 34 and question number 35. So you have to convert degree to radians. Think about which formula you will use and then check your answer in the next slide. Okay, so now let's do question 34 and 35. And this snapshot I have just taken from the formula sheet that I gave you in the beginning of the session for this module 9. So what does it say? To convert a degree measure to radians, you multiply by the number of degrees, what is given in the question, by 5 pi radians over 180. And conversely, to convert radian to degrees, you multiply by 180 by pi radians. Now, how are you going to remember this? So let me give you my trick to memorize or to remember the formula. So what is that trick? Let's see. So if you are going to do degree to radians. Now for this you have to at least remember the conversion factor, that your 360 degrees is equal to 2 pi radians. We also use this in the last slide on the questions, but then yes, this is the conversion factor that is going to help you to remember the formula. So how do we do it? So when you are given degree, remember this is the symbol, and when you have radians, you have to give it in terms of the unit of pi radians. So let's see how we are going to do. So we are going to multiply. Now because you will convert degree to radians, so remember in the numerator you will have pi radians. So it's actually, if you divide both sides by 2, I'll change color, then it becomes 180 degrees is equal to pi radians. This is the factor with which we are going to multiply. So if you are converting to radians, just see which result you want. You want in this question for radians, so pi radians on the top, and it will be divided by 180. That's the rule. Conversely, if you get a question where you had to do radians to degree, then we focus on the result. The result is degree. That means 180 degree will come on top. So you multiply 180 by pi radians. So this is the easiest trick to memorize the conversion from the two units. So let's now solve. So for answer 34, the angle given is 140 degrees. We are converting to radian. So without going to the formula also, we know because we want radian, so pi radian will be on the top and you divide by 180. So let's see what we get when we simplify. So 0, 0 will cancel. Pi radians, we are going to keep it like that. We'll not substitute anything for pi or try to change here because you want the answer in radians. So this is like a unit working just like degree. Now you just try to simplify 14 over 18. 14 divided by 18, you divide both by 2. Both are even, so you get 7 over 9. So this is your answer. Let's do 35 now. Now in 35, the only difference is angle is given to be negative. So the angle given to you is negative 260, but the formula to convert is same, so pi radians over 180. Keep the unit as it is, pi radians, and because you have a negative sign here, keep that like that. 26 divided by 18, so simplify. Both are even, they will go with 2, so you get negative 13 over 9 pi radians. That is the solution. Hope you have understood the trick, and this will help you for your exams and even remembering for further classes. Now it's time for all my students who have tried to solve all the questions in their notebooks to check their answers, or otherwise if some of these parts came for your exam, this is an answer key for question 16 to 32. So check and let me know in the comment section how many answers you got correct. This slide is an answer key for question 34 to question number 42. Please do check your answers. Try to first solve them yourself and then just use the slide for verifying your mistakes or correcting your mistakes or verifying your answers. So now we've come to one of the most interesting questions of trigonometry that we are going to be now solving, question 70 and question 71. These are given in your math book for all grade 10 students on page 423. Let's discuss two of them. Now here for question 40, let's read first. It is convenient to know the measures of some angles at both degrees and radians. Quite true. I know, I hope that by now you know the conversion as well. So you are given in this diagram, this circle, that you see the angles in degrees, right? What you need to do for part A, you copy and complete the figure at the right by writing the radian measure. That means in this question you are trying to convert from degrees to radians. So remember, what is the conversion factor? We want in radians, so we are going to multiply by pi radians divided by 180. Second one, describe at least one pattern of symmetry that you notice in the completed figure. So is there any similarity, any pattern that you notice? That's the second part of the question. So let's dive into little parts of solving it here, and then you can check your answer with the answer key. So when you convert degree to radians, you are multiplying by pi radians by 180. So if you see 0, it will not be any difference in radians. So it will be 0 radians or 0 pi radians. Now let's talk about 30 degrees. So you multiply by pi radians over 180. Similar calculation, 0 and 0 cancel. So 3 over this is pi over 6 radians. So you can fill in pi over 6 here. Similarly, for 45, if you do the conversion, it will come pi by 4. You do for 60, it will come pi by 3. For 90, pi by 2, and so on. Now out of this, I'm going to just quickly change color and fill in some which are very easy, because you know the conversion factor is 2 pi radians equal to 360 degree. So for this 360 degree, you will get here 2 pi radians. For 180, you will definitely get pi radians, half of it. And then for 270, if you can think on similar lines and tell me. So you are going to multiply pi radians over 180. Now why we are doing these angles first? Because these are your special angles, the basic angles at which one quadrant is finishing. So they are easy to compute. So both will go with 9. So 9 threes are 27, 9 twos are 18. So 3 pi by 2. Now let's change color and put in the value. 3 pi by 2. Now these are special angles. 0 to 90 is your first quadrant, 90 to 180 is your second quadrant, 180 to 270 is your third quadrant, and 270 to end 360 is your fourth quadrant. That's why I wrote these angles before. Now similar way you can fill in all other angles in between by using the same conversion factor, pi radians over 180. So that's your completed figure. You can check your answer. And for question 71, now let's see what it is asking. Through what angle in degrees and radians does the hour hand of a clock rotate between 4 p.m. and 7 p.m.? Assume the length of the hour hand is 6 inches and find the arc length of the circle made by hour hand during that time. So this is an interesting and important problem. So I will be solving this problem as the problem one for my 10 days of trigonometry course. So do watch that video on my channel. It'll be uploaded soon, inshallah. So you can check your answer for question 70 using this slide. As you can see, we've used the same measure, pi radians over 180. I'm going to highlight a few values here. So 0 degree came as 0 pi radians, 30 came as pi by 6, 45 came as pi by 4 radians, 60 is pi by 3, 90 is pi by 2. Going on to second quadrant, 120 is 2 pi by 3, 135 is 3 pi by 4, 150 is 5 pi by 6, 180 is pi radians, 210 is this one, 220 this one, and so on. So you can check your answers. All the angles from 0 to 2 pi or 0 to 360 degree have been converted into radians, and now it's easy for you to complete the figure. Coming to part B, where you had to do the similarity, the pattern noticing. As you move around the circle in 45 increments, the radian measures increase by increments of 4 pi. Right, that's the pattern. That is, the angle is changing from 0 to pi by 4 to 2 pi by 4 and so on. So there's an increment, as you can see here, by pi by 4 radians. For question number 40, please watch my video which I have uploaded few days back as day 1 of the 10 days of trigonometry series. I will provide the link in the description box. Thank you so much, and that video is a complete solution of question 70. Hope you enjoy. Next we have question 72 and 73. These two are also in detail solved in my 10 days of trigonometry session. So do watch the videos for the complete solution for these two interesting word problems on trigonometry. For question number 72, you can watch the above video. I have put the screenshot and the link in the description box so that you can have the detailed solution and understand well this important trigonometry word problem. So that brings us to the end of today's session. That completes part 1 of your solutions for the part 3 of trigonometry. For all my grade 10 students, thank you for watching. Make sure you like, share and subscribe. Hit that bell icon and press the subscribe button to receive notifications of all my upcoming videos. If you have any questions and queries, put in the comment section. I will be happy to answer them for you. Till then, this is Ms. Ruchika signing off from today's session. Bye students.